In this video, we are going to talk about L'Hopital's rule. What does this rule say? That if by applying the limit x approaches to a f of x over g of x, you get 0 by 0 or infinity by infinity, then in that case, you can write limit x approaching to a f of x over g of x equal to limit x approaches to a. Calculate the derivative of f of x separately divided by derivative of g of x separately. After taking the derivative of numerator and denominator separately, simplify that expression and then apply the limit. So this is how L'Hopital's rule works. Again, the question would be of limit. You apply the limit, and by directly applying the limit, either you get 0 by 0 form or infinity by infinity form. In this case, what you do is that you write limit x approaches to a f of x by g of x limit part, and then you separately take the derivative of numerator. Here it was f of x, so you calculate the derivative of f of x divided by separate derivative of g of x, and then simplify and then apply the limit. So this is called L'Hopital rule. Let's understand this method by solving a question. We have to find the limit of when x is approaching to 2 on a function x square minus 4 over x minus 2. Now it's a question of limit. It has nothing to do with derivative at the moment. So every question of limit begins, as you have seen in the previous videos, by directly applying this limit, that is by putting x value as 2 in the expression. So what do you have? Limit x approaching to 2 x square minus 4 over x minus 2. So by putting 2 in the places of x, you get 4 minus 4 over 2 minus 2. It is 0 by 0. Now if you can recall from the previous lectures that if you get 0 by 0, which is an undefined form, you go back to your question and modify your question, meaning that either you factorize or rationalize or simplify your expression and then apply the limit and see what you get. But now we are trying to use L'Hopital rule here. So remember that whenever you get 0 by 0, you can apply the L'Hopital rule. What does the L'Hopital rule do? You write the limit part as it is. You calculate the derivative of numerator separately. What is the derivative of x square minus 4x? It is 2x. Divided by derivative of denominator separately. Denominator is x minus 2, its derivative is 1. L'Hopital rule is applied now. You have calculated the derivative of numerator and derivative of denominator separately. Now you simplify. This is the last simplification step that we can do. And after that, we will apply the limit, which gives us 2 into 2, which gives us 4. So this is how L'Hopital rule works. So what you can do is, whenever by directly applying the limit, if you get 0 by 0 or infinity by infinity form, you can apply the L'Hopital rule. What does L'Hopital rule do? Calculate the derivative of numerator separately, calculate the derivative of denominator separately, and simplify. Don't forget to simplify. After last simplification step, you apply the limit. Let's do another question. We have to find the limit when x is approaching to infinity for the function x to power minus 4 by 3 divided by sine 1 over x. So it's a limit question. The first thing that you do in every limit question is you directly apply the limit. Don't simplify the expression at the moment. Just directly apply the limit and see what you get. So to see that what I get in the numerator, I will simplify it on the side. Infinity to power minus 4 by 3 can be written as 1 over infinity to power 4 by 3. Infinity to power any positive number is just infinity, and 1 over infinity is 0. So in numerator we are getting 0. You can see that I have solved infinity to power minus 4 by 3 on the side, and I got my answer 0, then I put here. Now I'm trying to see what I get when I solve or simplify sine of 1 over infinity. 1 over infinity is 0, sine 0 is 0. You can see that in your calculator. So I'm going back up and put here 0. So you can see that by directly applying the limit, I got 0 by 0. Now that we have understood the L'Hopital rule, we know that whenever we get 0 by 0 or infinity by infinity, we can apply the L'Hopital rule. So that's what we are going to do here. Write the limit part, x to power minus 4 by 3 divided by sine into 1 over x. Now L'Hopital rule. X approaches to infinity, derivative of numerator separately. What is the derivative of x to power minus 4 by 3? It is minus 4 by 3 x to power minus 4 by 3 minus 1 divided by derivative of denominator separately, which is sin x derivative is cos x, but here cos 1 over x because that's the angle, and then derivative of the angle. Here angle is 1 over x, which can be written as x to power minus 1. So its derivative is minus 1 x to power minus 1 minus 1, which is minus 1 into x to power minus 2, which is minus 1 over x square. So the derivative of 1 over x is minus 1 over x square, which we will multiply here, minus 1 over x square. See, we have applied the L'Hopital rule, but we will not apply the limit yet because we have to simplify this expression that we got. So let's simplify this expression. Minus 4 by 3 x to power minus 7 by 3 by taking the LCM divided by cos 1 over x, and this minus sign here, it makes this sign positive, so we have 1 over x square here. Let's continue to simplify. This x square comes up, and here you have x to power minus 7 by 3 whole divided by cos 1 over x. We will continue to simplify. We have x to power 2 minus 7 by 3. By taking the LCM, we get minus 1 by 3 over cos 1 over x. We will still continue to simplify. We will bring x to power minus 1 by 3 down. It becomes x to power 1 by 3 cos 1 by x. Now that we have simplified it to its very last step, we will apply the limit. 4 by 3 is the constant. We are simply taking it out and applying the limit x approaches to infinity on 1 over x to power 1 by 3 cos 1 over x. When we apply the limit, we have infinity to power 1 by 3 cos 1 over infinity 1 over infinity to power 1 over 3 is just infinity. 1 over infinity is 0, so we have cos 0. Cos 0 is 1, so we have in denominator infinity into 1, which is just infinity. 4 by 3 into infinity. 3 into infinity is just infinity. 4 by infinity is 0. So this is how we apply the L'Hopital rule. Please know that whenever there is a question of limit, you don't simplify in the beginning. You just directly apply the limit. If you get 0 by 0 or infinity by infinity, you go back to your question and you can apply the L'Hopital rule. Separate derivative of numerator, separate derivative of denominator, and see that we have spent time on simplifying after applying the L'Hopital rule. Simplify to its very last step and then apply the limit. It will give you some definite answer. Let's try to understand L'Hopital rule by doing another question. We have to find the limit x approaches to 0, 1 minus cos x divided by x square. As we begin every question of limit by directly applying the limit, here we get 1 minus cos 0 divided by 0 square. Cos 0 is 1, so 1 minus 1 is 0 divided by 0 square is 0. Again we got 0 by 0. It means we can apply the L'Hopital rule. Limit part as it is. Now the application of L'Hopital rule. Numerator derivative. Derivative of 1 is 0 minus cos x derivative is minus sin x. Divided by derivative of x square which is 2x. We have applied the L'Hopital rule. Now we are going to simplify this expression. Gives us sin x divided by 2x. We cannot simplify this any further, so we will apply the limit. We can see that when we directly apply the limit, we get sin 0 divided by 2 into 0. Sin 0 is 0 and 2 into 0 is 0. We again got 0 by 0 form. We will apply again the L'Hopital rule. So there is no restriction on how many times we can apply the L'Hopital rule in one question. As long as you got 0 by 0 or infinity by infinity form, you can always apply the L'Hopital rule. So again applying the L'Hopital rule, sin x derivative is cos x divided by derivative of 2x is 2. You can see that every time we apply the L'Hopital rule, we will have to simplify the question. But now this expression is already simplified to its very last step. We cannot do much, so we will apply the limit. It gives us cos 0 divided by 2. Cos 0 is 1 by 2. So this is how we apply the L'Hopital rule to solve a question of limit. Let's solve another question. We have to find the limit x is approaching to 0 ex minus 1 to power x square. Let's begin solving this question. So it's a limit question. Limit question begins by directly applying the limit. So we get x approaches to 0 ex minus 1 over x square. By directly putting x equal to 0 in this expression, we get e power 0 minus 1 divided by 0 square, which is 0. E power 0, any number to power 0 is 1 minus 1. We get 0 by 0 form. We get 0 by 0 form, so we can apply L'Hopital rule. Limit x approaches to 0. Derivative of numerator separately, which is derivative of ex is ex minus derivative of 1 is 0. And derivative of denominator separately, which is 2x. Simplify this expression, e power x over 2x. We can't simplify any further, so we will apply the limit. And when we apply the limit, we see that we get e power 0, 2 into 0. E power 0 is 1, 2 into 0 is 0, 1 over 0 is infinity. Now remember that whenever we get infinity only, we will have to split our question into two parts. We will find the right hand limit and left hand limit. Right hand limit says limit x is approaching to 0 e power x over 2x. Since putting the limit in e power x over 2x gave us infinity, so we will split this limit question into two parts, right hand limit, left hand limit. And left hand limit is limit x is approaching to 0 minus e power x over 2x. Both answers initially we will put infinity, but then we will decide on the sign of infinity. So x approaching to 0 from the right of 0. X is somewhere here. Pick some x from here. Let's say it is 0.02. So the function on which we have to decide the sign on is e power x over 2x. E power x is taken as 0.02 divided by 2 into 0.02. We only have to see the sign of this term. So e power 0.02 is some positive number divided by 2 into 0.02 is positive number. Positive by positive is positive. So we will go back up and put here positive sign along with infinity. So we are done with the right hand limit. Now for the left hand limit, we have to decide only the sign of infinity. So in this case, x is approaching to 0 from the left of 0. Pick some number here, minus 0.01. So if we pick this x and we have to decide the sign on e power x over 2x e, and x is minus 0.01 divided by 2 into minus 0.01. Know that the answer of exponential function is always positive, no matter here you have a negative number. So you can also check it in calculator. E power minus 0.01 is going to be a positive number. So in numerator you have positive answer, and in denominator 2 into minus 0.01 is definitely a negative number. So positive by negative is negative. So here along with infinity on the left hand limit side we will put a negative sign. So this is how we apply the L'Hopital rule, and then we follow the steps that need to be taken when we get infinity. That is, we split our question into two parts, put the answers infinity, and then decide on the sign for the left hand limit and the right hand limit separately. This question is completed. Let's do one more question. We have to find the limit of when x is approaching to infinity, x over e power x. Every question of limit begins by directly applying the limit. So when we do that, we get infinity over e power infinity. Infinity over e power infinity is infinity. So remember, whenever we get infinity over infinity or 0 by 0, we can apply the L'Hopital rule. So what does the L'Hopital rule do here? Derivative of numerator separately, derivative of x is 1 divided by derivative of denominator separately, derivative of e power x is e power x, and then we simplify. But this expression is already simplified, so we will simply apply the limit. It gives us 1 over e power infinity. 1 over e power infinity is infinity, so we get infinity. 1 over infinity is 0, and this question is done. In this video you have seen that if in a limit question you get 0 by 0 or infinity by infinity form, you can apply L'Hopital rule. And in the next video you are going to see that if in a limit question we get 0 into infinity form, then how shall we solve that question.